In this lesson, we will be partitioning a directed line segment, and we're going to be using both a graphical and a numerical approach. Locate point E along segment DF, which partitions directed segment DF in a 1-to-1 ratio. And we're going to start with the graphical approach. Now, we are calling this segment DF. That is the same as segment FD, but in this lesson we want to pay attention to which letter comes first. And so we want to partition from D to F so that the point E splits the line segment in a 1-to-1 ratio. What we want to do is find the slope, the rise and the run between points D and F. My rise is 2 and my run is 8. So because I want to split this line segment in half, instead of going up 2 and to the right 8, I want to go up half that far, up 1 and to the right 4. And this is going to be point E, and the coordinates of point E are going to be 1, 1. And again, I've used a graphical approach. Now the same problem, but this time using a numerical approach. I have my coordinates of point D, -3, 0. Coordinates of point F are 5, 2. And because I want to locate point E, which partitions the segment in a 1-to-1 ratio, that really means my point E is going to be my midpoint. And so the midpoint is found by averaging your x coordinates and averaging your y coordinates. In other words, add the x coordinates, divide by 2, add the y coordinates, divide by 2. Now simplify your fractions. I have 2 over 2, and then the y coordinates are also 2 over 2. So the coordinates for point E are 1, 1. And that's using a numerical approach. And this was an interesting numerical approach because when we're talking about a 1-to-1 ratio, we really want the coordinates of the midpoint. All right, here's another example. We want to locate point I, which lies along segment JM, and partitions directed segment JM in a 1-to-2 ratio. Now this means we want to find the point that lies 1/3 of the way along the segment. Because if we're talking about a 1-to-2 ratio, 1 part plus 2 parts, that's 3 parts. So let's measure from J to M. Let's do our rise. That's a rise of 3. And let's do our run, a run of 6. So I want to go 1/3 of that rise and 1/3 of the run. So let's go up 1 and to the right 2, and there will be my point I. Now the same problem, but using a numerical approach. In this numerical approach, I have the coordinates for J and M, and I want to find the coordinates for point I. We'll call it x, y for now. And what I want to do is, without graph paper, I would want to know the distance between the x coordinates in J and M. So I'm going to do 3 minus -3, and that's going to be 6. And I'm going to find 1/3 of 6, which is 2. And because I'm starting at point J, heading toward point M, I want to add 2 to what was the x coordinate. -3 plus 2 equals -1. So I know the x coordinate of point I will be -1. Now let's do something similar for the y coordinate of point I. First of all, I want to say how far is it from 1 to -2, or from -2 to 1, right? What's the distance? So I'm going to subtract 1 minus -2, and I'm going to get 3. Now I'm going to take 1/3 of 3, and that's 1. But what you want to remember is we're starting at point J. And so the y coordinate of point J is -2. I want to add 1 to it, getting me a y coordinate of -1. So the coordinates of point I will be -1, -1. All right, let's do one more example. And this is a graphical approach. We have directed segment TC this time, right? And we want to locate point A along that segment, starting at T, going towards point C. in a 2 to 3 ratio. So if it's 2 parts to 3 parts, that's a total of 5 parts, right? So let's figure out the rise and the run between these two endpoints. So it's going to be a rise of 5 and a run of 10. So what I want to do is I want to think about 1/5 of that rise and 1/5 of that run. And I want to find these little points that lie along segment TC. So there's 1/5 of the run. That's 2 to the left and 1 down. And I'm going to do the same thing. There's 2/5, there's 3/5, 4/5, and that's 5/5 of the segment. Now remember, we want to partition this segment in a 2 to 3 ratio. That means starting at point T, 2/5 of the way towards point C. This will be point A right there. All right, same problem, but a numerical approach. Realizing my coordinates for point C and T are listed, I'm trying to find the coordinates for point A, which we'll call x, y. Let's find the difference in our x coordinates to figure out how far apart the x coordinates are. So it's going to be 5 minus -5, that's 10. And I'm going to do 2/5 of 10. 2/5 of 10 is 4. And because I'm starting at point T this time, going towards point C, I need to do 5 minus 4, which is 1. So the coordinate, the x coordinate of point A is 1. Now similar approach for the y coordinate. 4 minus -1 is 5. The y coordinates are 5 apart. I want to do 2/5 of 5, which is 2. And because I'm starting at point T, I'm going to subtract that 2 from the 5. 4 minus 2 equals 2. And so my y coordinate is 2. And there is my point A with coordinates 1, 2, and that was the numerical approach.